Hello, everybody, and welcome to Lab 1. On the screen, you will see that I have SPSS open. I have the questions for Lab 1 open, and then I have the independent samples t-test data that I've collected in the background. And so what the purpose of this video is to help you um, through the SBS part or SPSS part of Lab 1. And so I'm going to show you how to conduct an independent samples t-test, which should help you answer the questions for Lab 1. As a reminder for Lab 1, you really don't need to do an APA style paper. Answering the questions directly on the actual lab document underneath each question is quite sufficient. So that way we can maintain the organization of all the steps that you need to complete as part of Lab 1. Let's go ahead and get started with putting our data into SPSS. There is a way to import data directly into SPSS, but because our data points, the number of data points we have, are not that large, I just prefer to copy and paste my data into SPSS. So because we're doing an independent samples t-test, you're going to see that I have several data points here, and I have it sectioned by classes because the purpose of an independent samples t-test is to compare the mean averages or the means of two different groups. So I need a data set that tells me what the different groups are. So as you can see here, I have a column that says class, and I have a variable there that says one. This is a categorical variable. And then I also have a variable here that says two. So anyone that is categorized by a two is part of class two, and any data point that is categorized as a one is a student that is located in class one. And so what you'll see here is I'm going to only be using column B today for my data, but I do have a column C and a column D. What you're going to see here in column B is that I have FSA scale scores for each student. As you can see, each one there represents a member of class one or a student in class one and the scale score that they had. And so I guess the question that I'm asking today and the statistical analysis that I'm doing today is the average FSA score or is the mean FSA score for class one statistically significantly different than the average or mean FSA score of class 2. And so as you can see here, I have the scores, and I'm just going to go ahead and I'm going to copy and paste the scores that I have for class 1 and 2. Okay. Then I'm going to, paste. My apologies. Oh, I'm in variable view. That's why it's not working. Excuse me. Paste. And as you can see, I have my data points in there. Let's see. I want to go to variable view now. We're going to make sure that our types of data are numeric. It looks like it has taken my class as a variable name. We're going to change the second variable name to FSA scale. The measure for this class is going to be scale, and the measure here is going to be nominal. Excuse me. Cancel. All right, so there again, what we did is we put our data points in. And as you can see, my data looks very similar to how it looked on my spreadsheet in Excel. On my left column, I have the classes. On the right column, I have the FSA scale scores. And you can see that anyone that had a blank, it put a dot in there for me or a period. Now I'm going to actually go up and I'm going to run my independent samples t-test. I'm going to click analyze. I'm going to go down to compare means. Compare means. And then once I go to compare means, I'm going to go to, independent samples t-test. And when I get to independent samples t-test, you're going to see there that it gives me the option to begin classifying my variables as test variables or group variables. So for this one, you can see that my grouping variable would be actually my class. So that's a grouping variable. My test variables are FSA scale scores. Then I'm going to click options. When I click options, it gives me the option to choose a 95% confidence interval, which I am going to leave at 95%. I'm going to click continue. I'm going to, define my groups. When I click on define groups, it gives me the option to label my groups. I have group 1 and I have group 2, so I'm going to leave that the way that it is, the way that I've currently have it numbered. I'm going to click continue. And then once I do that, I want to make sure that the checkbox for estimate effect sizes is clicked as well, because you're going to need that for the lab. Okay. Now I click OK. And when I click OK, SPSS provides me with an output window. And so what I'm going to do here, is I'm going to make it just a little bit bigger so that way we can look at it together. And when you actually look at the output window, you're going to see that it gives you 3 tables. In the first table, you're going to see that these are descriptive statistics. It tells me my groups, which are class 1 and class 2. We have the total number as part of our sample. So in class 1, there were 71 students or 71 scores. The mean score was 350.65. The standard deviation was 12.043. And the standard error mean, was 1.429. If you look at class 2, or the second class that we're comparing to class 1, we had 51 scores for that class. There were 361.94 mean score, and then we had a standard deviation of 14.206 with a standard error mean of 1.989. When we actually get down into the next table, this is actually where we're going to start to look at the independent samples t-test. I'm not going to go too deeply into Levene's test for equality of variances for this lab, but I would like to just point out that if your sigma for the Levene's test for equality of variances is greater than 0.05, you read the top line for the independent samples t-test, and you would use the whole top line for your statistical analysis. If this sigma were less than 0.05, then you would use the bottom line, because we would assume that equal variance is not assumed. But again, because my sigma is greater than 0.05, I am going to use the top line. You're going to see that there is a critical t-value there. There is a critical t-values chart on page 214. You have your degrees of freedom, which is each sample size minus 1. So we have a total of 122 scores, and we subtract 1 from each of those, and that gives us a degrees of freedom of 120. We are using a two-sided alpha, and so we are looking there that it is less than 0.001. It shows us our mean difference, which is negative 11.293. We have a standard error difference, which is 2.384. And then we also have our confidence interval of the difference, which shows us our true mean value falls somewhere within that, that area. So it's negative 16.014 to negative 6.573. As you can see here, it's really important to note that your confidence interval, lower and upper, do not cross the 0 mark. Because both numbers are negative, it is not crossing 0. Therefore, that's another indication that our finding is statistically significant. If that number band or that range were to cross 0, that would suggest that our findings are not statistically significant. Then when we look here, at our third table at the bottom here, it says independent samples, effect sizes. For the purposes of this course, we use Cohen's d. The only area that I'd like you to look at here are the point estimate and the 95% confidence interval. The point estimate, we look at that as an absolute value. And so if we're looking at Cohen's d, we're seeing that's a negative 0.870. Because that is an absolute value, we can say that we have an effect size of zero point 0.9 if we were going to round up, or you can say an effect size of 0.87. Again, our 95% confidence interval here suggests that there is a statistically significant effect here, and because it does not cross zero, both numbers are negative. Let's see. Now I want to go back over to the questions here because there are a few more things that we need to do to be able to conduct this lab. So I just want to look at question 5 with you. And then for the next questions, 6 through 10, you can see another video that's available to you. So for question 5, it says, given the p-value and power of your independent samples test, what sample size would you need for an effect size of 0.8? Well, in my data, I've already reached that, but we can still calculate that information. So if you go to Analyze and you go to Power Analysis and you go to Means, and then you go to Independent Samples t-test, it's going to bring up a series of questions or boxes in which you can fill out to start calculating these measures. And so here, again, it says, given the p-value and power of your independent samples t-test or samples test, what sample size would you need? Well, we know our p-value, but we don't know what our power of our study is just yet. It's not there. So in order to estimate power, we can calculate the power based off the numbers that we have in our table. So our sample size for group 1 was 71. Our sample size for group 2 was 51. We know the population mean difference because the population mean difference is reported in the independent samples t-test table. So as you can see there, it says negative 11.293. Negative 11.293. And here, our standard deviations are not equal for two groups. One is 12.043, the other one is 14.206. So I'm not going to calculate the pooled standard deviation. If the standard deviation were equal for two groups, I would calculate the pooled standard deviation. In fact, I've included a calculator on the course resource page that you can use to calculate that. Because it's not equal, I'm going to check not equal, and then I'm going to enter the standard deviation for group 1, and I'm going to enter the standard deviation for group 2. So as you can see, 12.043 is my standard deviation for group 1. My group 2 is 14.206. And then I am using a non-directional two-sided analysis. I'm going to click OK. My significant level is 0.05. It gave me a power of 0.995. But when we go back to the question, it says, what sample size would you need for an effect size of 0.8? Well, we know what the study's power is now, so we can go back. We can go to power analysis. We can go to means. We can go to independent samples t-test. And then we can estimate power with the information that we've just collected. Hopefully that's enough to help you get started on that process. Please let me know if you have any questions. I am here to help, and good luck with this lab. There's another video to help you with the rest of the questions. Thank you so much.